Hello and welcome to day 11. So today we have a map of some galaxies and we're trying to figure out how far away they are from each other. They'll give you something about like a pathing, it doesn't matter, it's Manhattan distance only. So the trick is that each empty row and each empty column is expanding. So they're all going to be twice as big when we actually measure it. So since this is a pretty sparsely populated graph, I'm going to use a list of points. And don't worry about the blank X or Y, that's going to be happening for part 2. And then we'll take in our information, anything that's a galaxy, we'll add it to our galaxy's point. The next thing we're going to do is expand the galaxy in both X and Y directions. One trip up that might happen is if you start at 0 and go to the end, you'll have to figure out when to skip twice, or you may have other problems where you will increment things the wrong number of times. Or just never get out of the loop. Easiest way for me to do it is I just started at the max and then moved down, and then every time I found a row that didn't have anything in it, everything that was above that row or right of that column, everything bigger, I just made one bigger again. So everything basically is removed, and then we add it back in with a slightly bigger Y or slightly bigger X, depending on which one we're expanding. At which point our total is just going to be the Manhattan distance. So the absolute value of either X minus the other X, and absolute value of either Y minus the other Y. Cool, easy enough. So part 2, the trick is basically just that the number of expansions can be more than 1. So a lot of these puzzles, as we know, they either try to make things more complicated, or they try to include runtime, or do things where the naive solution would be more difficult to run. And that is the case here today. So if you had just done a graph of X times Y, and then you went through and filled it, and now each one of those rows is getting multiplied by 1,000,000 instead of by 2, you could spend all day or run out of memory. But since we did it as a point graph, this is a lot easier. So and this solution actually works for part 1 as well. I obviously didn't know that at the time, but it is what it is. So I'm just going to take an expansion factor end, and then now I have this blank X and blank Y. And instead of moving the points around, I'm just going to count how many X's and Y blanks happen in between. So if something is like in the 10th column and there's 2 blanks before it, then that now has 2 blanks in there. Something that happens on the 15th column has 3 blanks. I know that there's a blank in between those 2 columns, if that makes sense. So all this logic is exactly the same, except for, as I said, we'll leave the X and the Y the same, and we'll just increase the blanks. And then our totaling gets a little bit different. So now we need to do the absolute value of the X minus Y, because that part still needs to be added in. But then now we also need to add the absolute value of the blanks. So we take the number of blanks in between each, and then we multiply it by the expansion minus 1. I got tripped up on the fence post problem and wasted like 5 minutes debugging that for no reason. So the reason the expansion minus 1 is because otherwise you've already counted the original one in here. One of those million is counted in this group. So you don't want to count twice, basically. Anyway, that's it. But by doing it this way, all of our stuff is exactly the same as part 1. We're running through it just as many times. Our amount of space that we're using is just as big. We'll just have all of the galaxies have exactly 1 data class instantiation, and that's it. And as I said, like this can actually be used for part 1 as well, just by passing 1 as for the expansion factor. Anyway, that is it for today, and I will see you tomorrow.